Okay, on my previous video clip we looked at how to draw net development as an orthographic drawing. This time we're going to look at a 3D object. In this instance I'm just using a box as a 3D object, okay, and how to draw this as a net development. So for instance, if your project would be, so for instance, some kind of piece of furniture or a house or an architect or some kind of building, you would do your orthographic drawing this way. So you'd have a plan view, front view and the side views, okay? So it's slightly different, however it's the same thing depending on what you're designing and what your object is. So basically I'm going to start with my plan view. So my plan view goes at the top of my page. Same as before, I've drawn my border and I've got my name, scale, and this time I'm going to do it 1:1, so I'm going to do it full scale, okay, and the title box, just call it that, okay. So I'm just going to measure off my box, it just makes it easier. So that is, the box is 115 millimeters, okay, tall. The width of it is 45 millimeters and the depth is 40. So again you can see it's rectangular in shape, it's not square. So we're going to start up here with our plan view. Okay, so remember our plan view is looking from above, looking down from it, or a bird's eye view. Okay, so I know the width of it is 45, okay, and the depth is 30, so it's 45 by 40. So top of the page, centrally, yeah. Okay, what you could do, again, you could measure your width of your page, roughly find the centre, which is around about there. So again, we could just start there and then split the lines. So they just start at the top of the page. Okay, so we all start with our plan view. So I said 45 millimeters, didn't I? So remember, we're drawing this at full scale. Okay, so it's going to be 45 millimeters on your piece of paper. Okay, so I'm going to measure 45, and the depth, okay, is going to be 40. So I'm then going to draw 40 like so. So basically my top view of this is just going to be, I would say square, but it's not really a square. It's rectangular. It's more square like, because it's only slightly different measurements for the width and the depth. So that's my plan view done. Simple as that. Okay. Then I'm going to do my front view. So the front view would obviously be looking from the front. Okay. So that's my front view looking across. Okay. So I know that width. But what I'm going to do, I'm going to draw some lines, some guidelines downwards. Okay. So I don't have to keep measuring. So the guidelines, and remember these guidelines need to be nice and light. And just run them down your page. Line them up, okay, and run them down your page like so. So you've got your two guidelines. So then your front elevation is going to sit in there somewhere. Okay, I did say it was 115, didn't I? So the height of it is 115 millimeters. Again, don't forget, because we're doing it 1:1, it will be 115 on a piece of paper. So I'm going to start around about there. I'm just going to get my ruler, I'm going to measure 115, so I'm going to take it down a little bit low, so I'm going to go to about there, it'll just about fit on, so 115 is there, so I'm going to draw directly onto that guideline, but I'm going to be obviously a little bit harder. So 115, 110, 15 is just there. Okay, and because I've got these two guidelines, I don't have to remeasure, because I've already done that previously, so I'm going to draw my horizontal line there. I'm going to draw my horizontal line at the bottom as well. Okay, and then up, like so. And you can see it's slightly darker than the guidelines. Okay, so you can obviously differentiate from the two. Okay, what I'm then going to do is, my box is symmetrical, so the left side and the right side are exactly the same, so I'm only going to draw the one side. Okay, but again, what I'm going to do, I'm going to draw some guidelines across. If your sides are different, then obviously you would draw both sides. If you've got an object which is obviously shaped differently, not symmetrical like mine, like a box, then obviously you draw both elevations or both sides. Okay, so again, I've got my top. Okay, so now I'm drawing that view. So The depth, remember, is this distance here, okay, and the depth up here was 40 millimeters. So basically, I'm going to bring my drawing across to here, so that's going to be the edge of my box, and then I'm going to measure 40 millimeters for my depth, because obviously this is a side view, okay, like so. And again, take it down like that, and across like that, okay. So you can see I've got my plan, which is at the top of the page. Then I've got my front view, which is in line with my plan. You can see that from my guidelines. And then I've got a side view or a side elevation, again in line with my front view or front elevation to the right. Like I said, if I was looking at, when I looked at different ways on this box, if it was different, I would draw the other elevation as well. But because I know it's the same, you only got to draw the one elevation. Okay. Here you're going to put the title of each of these drawings. So this one's going to be plan. Okay, and you'll notice the edge of the P lines up with the edge of your edge of that drawing. And the same with here. I'm going to put front view. Okay, again that lines up, and then side view. Okay. It could be side view, side elevation, it doesn't really matter. Okay, so you've labelled up your drawings. What you then need to do is then add your dimensions. Okay, so you're only adding dimensions so whoever's reading the drawing can understand what the size of the object is. So all we really need is the height, the width and the depth. And you do exactly the same as do exactly the same as you do with the net development. So again, we've got two leader lines which goes to the end of the object where you're measuring. Remember, these are slightly lighter than the actual drawing itself. And again, don't forget, these do not touch the object. What you're then going to have is, in this case, a vertical line running between those two leader lines, and then again you're going to have some filled in arrows. And we said that was 115 millimeters. Remember, we are working in millimeters, so it's always going to be millimeters. So we're going to just put 115. You do not have to put millimeters. You just got to put the figure. It's taken it as in millimeters unless stated. So again, you can see it also is running down the line as well. Okay, so you can see the two leader lines at the end, which obviously the ends are where you're measuring. Your vertical line. Your arrowheads touching the leader lines, and then your dimension in the centre. Remember, this dimension does not change. Whatever the scale is, that will still be the size in real life. So if that says 1 to 10, okay, that's still going to say 115. Your drawing would be a lot smaller, because obviously you scale it down. But that measurement is what you want it to be if actually I was going to construct this, or you wanted to construct this. Okay, so I'm going to do the same on this side. Two leader lines. This time there's going to be a horizontal line. Two arrowheads like that, and we know this was 45 millimeters. No, this was 40 millimeters. Sorry, and then I can put 40 there. That's my side view. Okay, all right. And what I would do as well, then I would just squeeze a dimension up here, a little bit tight, but I will still do it up there. So I'll do it there. So leader lines, horizontal line, two arrowheads filled in, and we know that's a 45. That's a 40. That's a 45. Okay, does that make sense, folks? Okay, and 45. Ideally that should be below that border, but it doesn't really matter. So that's really basically how you simply draw out an orthographic drawing in third angle projection drawing. Okay, and I expect that for anybody's project which is going to be more of a 3D object than like a net development. Okay, alright, so you've got your plan view, you've got your front view, you've got your side view, you've got your dimensions. And remember, your dimensions do not change with scale. It doesn't matter what the scale is, the dimensions still be the same as what you want the object to be in real life. Okay.